Hello, let's talk about this equation here. This is another conic section. I think this is an ellipse. We've got these two coefficients. We've got the x squared and y squared, and they're different numbers. I think this is going to be an ellipse. It will be an ellipse. Hopefully the numbers work out nice here. Let's see what happens. Now, to put it into standard form, and I could remind you what that looks like, but we'll see in a second. You need to complete the square. You need to complete the square on the x's and on the y's. So you got to group this together here. I'm grouping these x's together, and as I group them, I can't complete the square when there's a coefficient on x squared. So I got to get that 2 factored out. So it's interesting. I'm grouping the x's together and factoring out the 2, which made that a 4x. And then I leave myself a space to add the appropriate number to complete the square. Same with these y's. I factor out the 5. I'm left with y squared plus 2y when I factor out the 5. And I'm going to add the appropriate number here to complete the square. So I've grouped the y's together, factored out the 5, grouped the x's together, factored out the 2. I'm going to add the 7 over to the other side. And now I'm going to complete the square. Let's see, I'm going to add the appropriate number here. It's half of this number squared. Half of this is a 2. When you square it, it's a 4. I'm going to add a 4. Normally, you would go over to the other side and add a 4, but hold on. I added a 4, but it's multiplied by a 2, so I'm really just added an 8. So I'm going to add an 8. Right here, I take half of this and square it. That's a 1. I'm adding a 1 to get a perfect square trinomial. But I really added a 5, so I'll go over here and add a 5. Well, I just completed a couple squares. This is now x plus 2 squared. And this is 5, and this is y plus 1 squared, and this equals 20. Standard form of an ellipse wants this to be a 1. So we divide by 20, and we make that a 1. If I divide by 20, I divide by 20, I divide by 20, I divide by 20, and so now I get x plus 2 squared over 10. Y plus 1 squared over 4. Yep, and that's a 1. All right, we are in standard form. And there's a lot of information here about this ellipse. The center of the ellipse is that HK. The standard form had a minus sign in there, so the H is a -2 and the K is a -1. The center is -2, -1. In my notes, I had this number called a squared. The truth is, it is a squared, and this number is called b squared. But the way our book talks, whatever's the bigger number is what you call a squared. So it could be that a squared, if the bigger number was underneath the y, maybe that's the a squared, and the smaller number is called b squared. So they could be in different places, but the bigger number is what you call a squared. And so, what is a? A is the square root of 10, and b is 2. All right, I want to start graphing this and explain what that means. So I'm going to get rid of this evidence here, where I completed the square and turned it into standard form. That was fun. But now I'm going to try to graph this thing. The center is -2, -1, -2, -1, right here. And then what you do from the center is you go, well, this number was underneath x. You go over square root of 10 and square root of 10 to get to the endpoints of the major axis. So you go over the square root of 10, which is just a little bit more than 3. 1, 2, 3, roughly there. And 1, 2, 3, roughly there. Those are called the endpoints of the major axis, the longer axis. From the center, you also go up, because it's underneath y, you go up 2 and down 2. So up 2 and down 2. and that gives you to the endpoints of the minor axis. That's the minor axis, that's the major axis. It turns out the endpoints of the major axis are called the vertices. That's the endpoints of the major axis. They're called the vertices of the ellipse. There's two of them. Now, how the hell did I get there? I went over -2, down -1, and then I added, okay, so I took -2 and added, okay, hang on. I took -2 and I added and subtracted the square root of 10. That got me over there and over there. The y value for both of those is -1. So there they are listed together. -2 plus and minus the square root of 10. That's how I did that. Down -1. Those are the endpoints of the major axis, or the vertices. The endpoints of the minor axis are a little easier numbers. We went up 2 and down 2. By the way, they're called the endpoints of the minor axis. Endpoints of the minor axis. And let's just list those here. There's 2 of them. There's 2 of those too, but I just put them together with that plus and minus. The endpoints of the minor axis, let's see, -2, and then up here, what did I do? I came up here, so that's a 1, and I came down here, that's a -3. Yeah, so -2, 1, and -2, -3. Yeah, there they are. Cool. You know, the ellipse is this shape here. Try to draw it. It's not bad. It's not a circle. It's elliptical. Sometimes I like to think of it as a circle with 2 radiuses. It's got that radius and that radius. That's kind of a lie, because there's actually a bunch of different radiuses in between that. But it's sort of cool to think of it as a circle with 2 radiuses. Whatever. So now there are these points called the foci. There's 2 foci. They live on the major axis, and they live this distance c away from the center. A distance c away from the center. And the truth is, this is always true with ellipses. You should understand this, memorize this. A squared minus b squared is c squared. So, 10 minus 4, that's my a squared and b squared, is c squared. C squared is 6. I'm getting down here to the bottom of the video, sorry. C squared is a 6. And so what is c? Plus and minus the square root of 6. And so I move over plus the square root of 6, and I go over minus the square root of 6. If I want to list those points as the foci, there's 2 of them. One of them would be -2 plus the square root of 6, comma, -1. The other one is -2 minus the square root of 6, comma, -1. I could have listed them together like I did the vertices. But there's the foci, a distance c from the center. That's pretty cool. There's one other thing. To measure how elliptical the ellipse is, I mean, they can be long, skinny ellipses, or they can be kind of almost circular ellipses. There's a number called the eccentricity of the ellipse. The eccentricity of the ellipse. And the eccentricity is often referred to with this number E, I guess, but it's not the number E, just this letter E. And it's the ratio of C over A. So the eccentricity of this ellipse is the ratio of the C over the A. What was the C? Square root of 6 over the A, which was square root of 10. So it's just a number. Whatever that is. Damn it, I forgot my calculator. It's a decimal. It's a little square root of 6/10. It's square root of 3/5. You should decimalize it. I tell you what though, it's always a number between 0 and 1. The eccentricity is always between 0 and 1. When those foci are really close to the center, then the eccentricity is closer to 0. And when the eccentricity is closer to 0, it's way more circular. When those foci are further out, close to the vertices, then that ratio of C to A is closer to 1. And when it's closer to 1, it's more elongated. It's, I don't know, it's more elliptical. It's more elongated. It's a more elongated ellipse. So this is probably roughly 0.5-ish, it's 0.7, isn't it? Yeah, it's about 0.7 something, I guess. I'm just doing it in my head. 0.75, 0.76, 0.77. Anyway, cool. I want to say, I guess I should say something else. So, you know, there is this major axis, and it's this distance was A and this distance was A. So it's kind of common knowledge that the length of the major axis is 2A. 2A is the length of the major axis. And the foci live on the major axis. They live on the longer axis. I mean, I guess we could say the length of the minor axis is 2b, but it seems like this comes up a little more often, kind of an important thing to know. All right, I guess I might have more to say about ellipses, but when I ask for give me all the important information about an ellipse, it's all this. The endpoint, the center, the vertices, the endpoints of the minor axis, the foci, the eccentricity. Please sketch a graph. Good job. All right, thank you.